All right, and with that, I am very, very happy to welcome Dr. Rafael Luna again for our first workshop in this year. We had him as our first speaker last year already, and he did a really great job, which is why we invited him again to give this workshop this year as well. He is currently the Associate Dean at Boston College, and additionally also the Director of Boston College's pre-health health program and the Gateway for Scholars in STEM program. He earned his bachelor's degree in biological sciences from Southern University in Louisiana, and then did his PhD at Louisiana State University. And after that, he performed his postdoctorate at Harvard Medical School and also stayed there to be an instructor. Additionally, he has also published the book, which you can see here, which is called The Art of Scientific Storytelling. We did provide the link to you in when we advertised this workshop. And if you want to learn more after this workshop, we encourage you to go and check out the book. And with that, I will just turn it over to Rafael. Thank you so much for coming again, and we look forward to your workshop.
Thank you so much. Thank you, Alice, Julia, and Aaron. Really excited to be here today. This is my third time speaking, the second time for this group. I'm really excited to be here today, and just want to say thank you. And I'm honored to be back. And let's get going. I think we have a lot on deck today, so we're going to try to cover as much material as possible. All right, so we have a lot to cover. The art of scientific storytelling, craft the elevator pitch using narrative elements. The game has changed. It's a global workforce. We need to become, it's ultra competitive now. And I do believe we can reinvent ourselves as storytellers, which is what I did throughout the course of my life. Here's the book, which was featured earlier. So thank you, Julia and Alice and Aaron. So let's start off with, what is a story? This is a really important question. And I think maybe you could put stuff in the chat, and then Aaron and Alice and Julia can monitor that. So what is a story? And I think this is a really cool, people always, we discuss this, but I think if we really try to break it down, we really want to break it down to this lowest common denominator. It's conflict, and if there's conflict, then there's resolution. And it's with this logical series of events centered on a protagonist. So this is really important, that it's centered on a protagonist, which is a main character. And it's really important to know, in your story, your main character is irrevocably changed. So what is a hypothesis? A hypothesis, you guys are a lot smarter than I was when I was in grad school. But I think that if we break it down to a fifth grade definition, it is an educated guess. So I think that's basically what it is. Oops. And if you combine scientific research with scientific storytelling, then all of a sudden, if you juxtapose those two concepts, then you have hypothesis validation, could help you resolve your conflicts through conflict resolution. And if there are any questions, please feel free to let us know. So part of the intimidating prospect of presenting research, your research career in an elevator pitch, how does it feel? And is it difficult? And some of you, said that your family loves you and they pretend to understand, but wouldn't it be nice to get them to really understand? That would be really cool, right? And how do you get, and so the scene is, your family gathering at grandma's house, and it's, what is it that you do? And you get that question, how do you respond to that? Because it's almost October, so there'll be a lot of family gatherings in November and December and the holidays. And so it'd be good to be prepared to answer that question. So we have all different types of fields in your group, I heard. So, it could be easy. I'm a bioengineer, biophysicist, I'm an artist, I'm a design engineer, or it's too complicated, or you wouldn't understand. Are you familiar with technical specific aspects of my research, and which may or may not go so well with your family members? I think there was 9% said that they come from family of scientists, so maybe they might understand. But if you're in a different field, they may or may not. Even if you're in the same field, molecular biology, I think back then when I graduated in 2004, I was doing cutting edge technology, bacterial artificial chromosomes. That's nothing. That was big back then. But now I start seeing grad students, early grad students, undergrad students, and high school students doing that. I'm I feel like a dinosaur, immediately when I went to my postdoc. And so even if they did understand, they're scientists, they still may not grasp some of the new concepts. So it'll still be important upon you to really communicate that to your family and to others. And so what we say, it's a great time for a story. It's 60 seconds. And we will do an exercise at the end where you get to do your elevator pitch. And so if we get started, how do we do this? And what's the order of operations for crafting an elevator pitch? So we're staring at a blank screen. What is it that we should do? Make an outline. Great, Bridget. That's a great call. Anyone else? She kind of nailed it. Let's see what else we got here. Draw it out. Great. I like that, the visual person. Great job, Vanessa. Define your mission statement. Great. I like that. Let's keep these thoughts. Think about applications. Why would a layperson care? Absolutely, Sonia. Define the question, then answer it. Oh, this is great. Think about who your audience is. Wow, this is fantastic. Okay, great. So we'll stop right there. Word vomit, then organize. Oh, I tend to do that too. So that's very good. And yeah, and so one way that, typically recommend is, let me go to the next. It's order operation of your storytelling hypothesis, crafting a storyline, basically an outline. And I think someone mentioned basically a storyline and data arrangement. Where's your data going to go? Where's the evidence? And then the fourth is tying it all together. So you can do it either way. And maybe this is just going to be pretty quick. And then we'll be doing this today, which I'm really excited about. So defining the storytelling universe. So if we do have to come up with a hypothesis, and hypothesis is with protagonist, antagonist, conflict, scene, resolution, and stakes. If we do have to do that, then I think it'll be incumbent upon us to really understand these terms. Because if you're going to put a story within one hypothesis, that's going to kind of define your universe and give the parameters of the extent of your story and the scope. And so with that, protagonist is the main character. Antagonists are all the other characters. But in your hypothesis, you're probably not going to mention all of the antagonists. It's just maybe the major one, right? And we'll go into this and try to explain how to do this. Conflict is a problem. Scene, where everything's happening. Resolution in the form of an action verb. And stakes is your research impact or why should anyone care, right? Like someone mentioned that in the chat, why should anyone care? And so there are elements of a narrative craft in your story. Have you guys seen The Lion King? Okay, you've seen it? Yep. Okay, I'm getting a lot of yes. Anyone that hasn't seen it, let me know, because I want to make sure I don't want to lose you either. Only about 1,000 times, Megan. Okay, so now we got our rock star here. She's going to help us out today, Megan. If you want to distill years of professional work into one sentence, you use the elevator pitch, and we're going to do, in your elements, and this is going to be part of your first exercises, protagonist, antagonist, conflict, scene, resolution, stakes. But you want one word, 1 or 2 words for each one. So, oops. And so if we talk about The Lion King, I guess, can we start naming out who's the protagonist in the chat? Simba. All right, we got that. All right, and who's the antagonist that would go? There are many antagonists, right? Good and bad. But who's Scar? Okay, you guys do know The Lion King. And what's the problem here? What's the problem? The kingship. Okay, the kingdom. Scar wants to be king. Okay, great. And so, like, if we want to, so this is great. So I like that word vomit that someone mentioned earlier. Let's throw everything down, right? And then you have to think, okay, I need to kind of craft it. Once I have all the pieces of the puzzle on the table, how do I craft this together? And so you're thinking of kingship. Scar wants to be king. They're fighting over the throne. He wants to get the throne back. So let's say the problem is the kingdom, right? Or the throne, right? Okay, perfect. Where's the scene? Is it New Jersey? Is Pride Rock in New Jersey? Pride Lands, of course, it's in Africa. I'm being silly. It's the end of the day, so I want this to be enjoyable, not only for you guys, but for me too. So the Pride Lands of Africa, right? And New Jersey. Yeah, the Pride Rock, New Jersey. Okay, that's right. That's cool. And then the resolution. So if you have your protagonist and your antagonist, this is really key here, is the resolution. If you have two, how do you covalently link these two, right? How do you link the protagonist and antagonist with resolution? Is with one verb. What's one verb that we could use to link both protagonist and antagonist, and that really shows the resolution, that shows what happened, everything, with one verb? Anybody? How do we covalently link these two? Or you could do the word vomit. Let's add a few more words, and then we can trim it down. Reclaims, oh good. Fight, okay, fight is good. Defeat, okay, defeats, okay, great. Battle. See, and I want this, this is really good. So we have fight, defeat, confront. Those are very good to start off with, but does it show the resolution, right? And so when you have like an elevator pitch, you don't have much time to explain what happened. So you really want that hypothesis to summarize your entire story of an elevator. So basically, we want an elevator pitch in 7 seconds, right? That's what this is, right? And displaces. So if you have displaces, let me go up to the top. Reclaims, defeats. These words shows what happens, right? And so not that the confront's wrong, but you just need to add more words. But word, the space is a premium, right? So we want to make sure we have that conclusion, right? Resolution. And stakes. What's at stake here? Who cares? Like, so what? So what if, you know, it sounds like, a problem with Simba and his uncle. Like, big deal. Like, I don't know about you guys. I have problems with some of my uncles, like, and I'm an uncle, so I'm problematic for some of my nieces and nephews. And so, like, uh, why should anyone care? Oh, beautiful. The circle of life. Yes. And prosperity of the pride lands. Yes, that's true. And all food going to the hyenas, the future of the pride lands, circle of life, messing up the ecosystem. Absolutely. All right, great, great. And so typically in the movie, it was the circle of life, right? And all these are right. And remember, when we do these, we're all going to have different elevator pitches, right? So you could do it in the way that suits you and relate to your family. All right, so let's put them all together. Let me get back to the slide. This is great. And so we have here Simba defeats Scar to reclaim African kingdom and maintain circle of life. Basically, you guys nailed it, right? You had Simba defeats Scar, reclaim African kingdom, and maintain circle of life. So I kind of cheated with 3 verbs, but it's all good. But you want that down at least because you can pitch the whole movie is within these 7 seconds, right? So now let's unpack this now, which you'll be doing. Structure is the basis of storytelling. So now what we have here is the hypothesis. Simba defeats Scar to take his rightful place as king, the pride lands of Africa, and continue the circle of life. That's our hypothesis, or something to that extent, right? And first T1 is what? When he leaves the pride, who does he meet in the Lion King? Timon and Pumbaa. Wow, you guys got the spelling right too. Wow, this is awesome. Because I actually don't know how to spell those names, so it looks right to me. All right, so you got T1, Timon and Pumbaa. Now, do they support the hypothesis in that first interaction? A yes or no? That's all we need. No. Okay, great, great. It's a no. Absolutely not. But if you're in the lab and your professor tells you to do experiment because it's on her grant and it comes out different in your experiments, are you going to tell her to write a new grant? And absolutely no to that too, right? And so what would you need to do? You have to do another experiment, right? And that's okay. That was a setback in your research. How many people don't get the results you expected? That's all right. And then T2, what's next? Who does he meet next? Nala. Okay, great. And does she support the hypothesis? Yep, that absolutely yes. And she tells him to go back, right? And there's evidence, right? And evidence to go back. So when you're telling these stories, it's really about evidence, right? So you're all scientists or engineers or in grad school using logic and reasoning. We want to use that. So we don't throw that out when we start explaining things. Grandma is highly intelligent, right? And so are your family members. We don't have to dumb it down. But what we could do is use a language that can communicate to them, but also with logical elements. So you have one evidence for, one evidence against. And then you have T3, and who does he meet next? Does anyone know? Rafiki, yes. And it sees his dad, right? And so in the vision, so Mufasa, that's right. And then does that support the hypothesis? Absolutely, it does. So you have 2 evidence for and 1 against, and then the climax is the highest tension point of your story, and that's the battle with Scar, right? That's pretty obvious, right? So now remember, we had Simba defeat Scar in that hypothesis. So now we're covering a lot of ground. But notice we didn't mention Timon, Pumbaa, Rafiki in our hypothesis, right? Even though they're important to the story, they're not as important as Scar and Simba, right? And then what happens after that battle? He defeats him. That's resolved. What if we have Simba defeat Scar to take his rightful place as king in the Pride Lands of Africa? What happens if we just stop there and we didn't do the stakes? Could we end the movie there? We could, right? But maybe that's not a Nature paper or a Cell paper, right? But maybe that's a journal that in your field, and that's okay. Sometimes you got to do what you got to do to graduate, and or maybe those results aren't coming out the way you have, or maybe the experimentation is not there yet, right? Maybe we have to wait another 10 years before the technology comes out to do some of the critical experiments. And but by that time, you're off and gone to greener pastures with your academics. And so the nice thing about the circle of life is that if you can see my cursor, you have the validation and you have your hypothesis resolved. And so with this is it's the circle of life. They come back to Pride Rock and all the animals come back, right? And so the light happens. So it's validation. So that shows that he's back to being the king, right? And with the raising of his new cub. And so this is my Lion King story where I have EIF5 molecule and it's EIF1. EI5 binds to EIF1. This is also EIF5, and where it's colored, where it's binds to EIF2 beta. And so 5 binds to EIF2 beta and EIF1. Which one's more important? Do I listen to Timon and Pumbaa, or do I listen to Nala? And you don't have to be a biochemist to understand this. We got some curves, binding affinities, and we do point mutations in red and green, and it disrupts affinity with EI5-2 beta, but we don't get binding affinities with EI5-1. I mean, with EI5-1. So that lets us know that the stronger interactions EI2 beta, so we should listen to Nala, right? And so this was our Rafiki, lets us know. Then we do our battle with Scar here, where we have the dissociation curves. Let us, in red is wild type, how it normally happens. The ribosome head opens, the start codon recognition, the head snaps, and it'll close that on start codon recognition to close the fluorescent molecule on it. It'll trap that in there, and then you'll have start codon initiation. But if there's a mutation that disrupts the interaction, the head stays open. This EIF1 fluorescent molecule is displaced by the stoichiometry of this unlabeled EIF1A, and then we'll see a rapid decay. That lets us know that this is important for start codon recognition, and then we predicted what happened in this figures 5 and 6, the yeast genetics, and then we placed this all back on our Pride Rock on the start codon decoding box. And then we were able to publish in Cell Reports. This paper was initially rejected at Cell, and part of it because I didn't put the story together right. And maybe if I did have the story, it could have been a contender, it could have been there or not, right? But I would have had a better chance if I would have explained this a little bit better. And so the C-terminal domain of eukaryotic initiation factor 5, that's the protagonist. The resolutions promotes. Start codon EI4 and EI2 beta are the antagonist. Dynamic interplays the conflict. Start codon recognition is the scene and stakes. So this was written using these 6 elements. That's the only way I was able to fix the manuscript that was rejected. And then now that you're expert storytellers, I want to make sure you guys get this concept. So I know that we're doing some biology experiments. We will get to some other ones with some chemistry and some other experiments as well. So we have messenger RNA, the 4E binds. So you have this protein, you have this protein that binds to the messenger RNA, and this molecule disrupts it. It's called the 4EGI1. It disrupts this interaction right in between. And it's called the EI4E 4G inhibitor, 4EGI1 drug. It interrupts right here. So now I ask you, which one's the drug? Is it the Grace ribbon model in with the alpha helices and the beta pleated sheets? Is it in gray, or is it this space bill model of spheres, which is the drug? And as you see, as the drug binds to the protein, it displaces, the 4G is displaced. So I'm asking a question, which one is the protagonist, which one's the antagonist? And my professor at Harvard Med, he asked me that same question. Is it the protein or the drug? And the numbers and the alphabet soup doesn't matter so much. It's really the drug. Okay. Okay, some people say drug. Anyone say protein? Oh, we got some people saying protein. And those that say protein, why? Based off what was in the previous slides, why would it be the protein and not the drug? And this one is an answer. Yeah, I would like an answer to see if there's, you guys, oh, somebody said protein. Yep, sorry. Yes, so the answer is the protein, but why? Yes, the protein, because it's changed. Great job, Genesis. Yes, and I think that's the really important piece, right? And those of you that said drug, please don't feel bad, because my professor at Harvard Med, he's a National Academy of Science member, and also part of the American Academy of Science with, at that time, I think 490 some publications. He must be almost close to 600 now. But he thought it was the drug too, right? And we were sitting there arguing, and he was like, well, it's got to be the drug. And I was like, well, does the drug change? Because remember, there's, let's go back if we can. We have these benzene rings here. I was like, does that open up? Does it cleave? Does it dimerize? What's it do? He said, no, it doesn't change at all. And we know that by NMR, that it definitely doesn't change. So right there, that told me automatically it has to be an antagonist if the drug doesn't change. Unless, but then I said, well, does the protein change? He said, yes. When the drug binds, you see the helix is extended and the 4G is displaced. So that means that this protein is changes upon binding this drug while the drug stays the same, and that's our protagonist. So great job, everyone, on this. And so if you did pick drug, then you're thinking the Nobel Prize. I'm definitely not on that track, but you guys may be doing that soon. All right, and so then here we fashioned this into the struck into a PNAS paper, and we're not going to touch base on that too much. We want to keep things moving. And so, and here we have a paper where, again, we have the 6 elements. We have 1A and EIF5. These are 2 protagonists. You have 2 protagonists, and here the antagonist EIF1 retains is the resolution. Scanning complexes are the scene and the stakes. And this is a chemistry one. So for those that are chemists, using magnetic levitation to separate mixtures of crystal polymorphs, this was quite challenging. And this one was a process of magnetic levitation. So this was our protagonist. This would took us 4 hours in Starbucks when they kicked us out in Harvard Square. But right before they did, the last 10 minutes, we came up with this as a protagonist and separated the resolution. Mixtures is the conflict, and the antagonist are the crystal polymorphs. And then we use this for a Nature Communications paper, and also a physicist used this as well. With comprehensive analysis and pulp fiber quantifies is the resolution, the mechanism of fiber bonding, and also with slice is our protagonist as well here. And it also uses in PNAS and JAX. And here, this is the engineering, materials engineering project. This guy was stuck, gave a talk in Germany, and it was quite difficult for him to publish his paper. So a lot of these papers, they were written in the form of stories, and they struggled initially with publishing their papers. So we have this multi-layers, the integrate, multi-layers are the protagonists, integrate resolution, energy density, and ductility are the antagonists, and reactive materials is the scene and also the stakes. And we discussed this. I was going on a train, and if you read my Nature paper, I talk about how I visit my daughter in Germany, who lives with me now in America, though, but she was raised in Germany. And I was late for a train to go see her, and I was not going to miss that train. He said, "When does it come?" I was like, "It's like it's in 20 minutes." He said, "Don't worry, it's right across the street. You got 15 minutes." And I was thinking about America, and I was like, "Wait a second. In America, I don't know if the train's late or coming, so let me go, because in Germany the trains run on time." I was like, I am not going to miss that train. So, or Julia's like, maybe not. Well, that was my impression, and so I'm not going to miss that train. So we had 15 minutes. We drafted this. He sent me this paper like about 3 years afterwards, and saying this is the exact same title we used in 5 that we drafted in 15 minutes in the hotel lobby with my suitcase, everything, going to go visit my daughter. So what you do here may lead to your publication, or it may lead to what you want to do later. So, and this is a paper in Nature, and this Nature Biomedical Engineering. This was also written. This student came in our workshop, one of my workshops, and she wrote on the board. And in that workshop, she actually came up with this title and crafted her paper, which she also couldn't get published, because it's just helpful for people to just see your story. And then, we have a few more minutes before we go on our break, but I want to leave some time for some questions before our break. Are there any questions? But it said that if you use all 6 elements, you have a long title. Yes. You saw my first one was really long. That was my first time I did that. And that was a rookie mistake. I probably should have it more lean. And so here I'm working with Dr. Arthanari, and he published this paper in Nature. It's like, Rafi, look at this method. We use this method, and we publish in Nature, right? And but it's hard to find the 6 elements in here. We know the stakes are fungal multi-drug resistance. Inhibiting is the conflict, or is it disrupting? Not really sure. Activator mediated interaction. It's kind of like the scene, but we don't really know what activator. Is it transcription, or is it a machine? It's not so clear. But everything was clear in the abstract and in the title. And I think that's the key, right? And so I think, so here that may have like 4 elements. You have inhibiting, which is, I guess, would be the resolution. The fungal multi-drug resistance is the stakes. And activator mediated might be the scene and an antagonist, not quite sure. But when he formed his story, he did finish that. So when you're trying to publish in Nature, then yeah. But if you do an elevator pitch, if it's a little bit longer for a long sentence, that's still fine for an elevator pitch of 7 to 10 seconds. All right, and so did want to use this paper as well that was crafted. Let's go through. There were some other questions. They say, what if your research is about a new methodology? How would you define the components of the story in that case? That's a great question. And since I went a little bit fast, let me go back. And if everyone can see here, so this is a new methodology published in Langmuir by a chemist. Synthesis of liquid core shell particles, solid, patchy, multi-component particles by shearing liquids into complex particles. Slice. If you know what that means, God bless you. Like, I don't even know what that means. But the story about this one, he had a new method, and he had this chemistry method to separate for not nanoparticles, but like mesoparticles, right? And so, and it was a very simple method. And he read my book, and he asked me to give a workshop for him while he was at UMass Boston. Now he's at Iowa State in engineering, or it says that here. But he says, here's this manuscript, Rafi. Why don't you put a story to this? And I looked at it, and there's no title in the abstract. But I was like, did you follow the book? Because if you read the book, it says you start with the title and then abstract when you write your paper, and then you do everything else. He says, no, we do it at the end. Rafi, just put a picture, just put a story to it. I was like, I'm not able to do that. And he says, didn't you read the book? He said, I read it. I said, did you read the section on the title and the abstract? Said, no, I skipped to the experiments, the results section in chapters 3 or 4. And I was like, well, why don't you go back and read from chapter 1 and then read and add the title. And what he had was, when he did put it together, the title and the abstract, he didn't have a name for his protagonist. And it was a new process. He says the name will come later. And I told him, I said, if you want to publish in a higher impact journal, you really do need to name your protagonist. So here he called it Slice. He used an algorithm called shearing liquids into complex particles to slice. And that helped. The audience needs to understand who to judge. They'll judge Simba, the protagonist. They'll judge Slice. They'll judge the process. So if you have a new methodology, you want them to be able to judge that. So naming that methodology would be really important. Is that helpful? Let's see. And how do you not sound very negative and turn people off when briefly discussing negative results? Well, I think if there's lessons learned in the negative results, right, that could be good, right? And there's always something to learn from it. And then maybe you can share with your family, or what could happen typically with the negative result, it leads you to a different question to reframe that hypothesis. But it's still important because you still got lab meeting. And lab meeting, you need to present negative results, right? And so you got to present whatever you have, right? And so I think you can still use the method, but this will help you know when you have a story or not, because then maybe you can troubleshoot your story with, do you have the protagonist? Do you have the antagonist? And so that would be quite key. So, okay. Let's see, were there any other questions that I did miss?
There is one from Katrina. How do you recommend sharing the story of your research when you yourself haven't figured out what the resolution is yet?
Oh, great question. And so when you haven't figured out what the resolution is, that basically you're at the arc here, right? And you're kind of in your character development phase of the experiments. Here, you're not able to predict what happens, but you might have a hypothesis similar to like writing a grant. What do you expect to happen? Is it a complex structure? Are you developing a device? Depending on your field, right? Is it methodology? And that is what you're trying to develop. But then it's like writing a grant proposal. What do you expect to see? And once you see that, how are you going to validate that? That's how I normally say that. So this is also going to be used for grant proposals. And T1, 2, and 3 are typically like preliminary results. I hope that's helpful. And we go through the exercise. Hopefully it'll help a little bit. And we do want to go over this exercise to kind of warm you guys up a little bit. We'll do, how do you explain to your grandmother the manner in which your research helps humanity? And we'll do that one, and then we'll come back for a minute, and then we'll go back to doing exercise 2, identifying storytelling elements in your research. So let's go ahead and move to that, if we can send them to the breakout rooms. So how did that go for everyone? Did everyone enjoy that, or like you struggled a little bit? That's not supposed to be that easy, because we haven't really kind of gone into it that much. So how was it for everyone? Taylor, you nailed it. It's hard to feel like you're omitting so many details. Isn't it hard for scientists not to just share every single aspect? And oh my gosh, this is great. Oh, this is great comments. Oh, they're coming in. We discussed. And so I think the key is, it feels almost deceptive to distill it down to layman talk. But I think sometimes when you do kind of distill it down to these narrative elements, and I think you can use these words, your storytelling elements, as proxies, so that you don't feel like you're dumbing it down, because these are the really elements of your story. And so, but you want to leave things out. Remember, in The Lion King, how good would that movie be if, we learned all about the elephants in the movie, then the zebras, and then it's turned into like National Geographic, and then Simba, and then like we throw evolution in there. I love evolution, I get that, but we throw evolution, climate change. What if we threw all that into that movie, Lion King? How would that have worked, right? but they really distilled it down, right? There were so many animals and so many characters, but they really distilled it down. And it was a movie, but it was really distilled down. We don't know how the animals got there, or how did Mustafa, gain the pride. There are a lot of things that were left out. And so one person in the previous, they mentioned that how do you troubleshoot, right? And I think, and then also I joined one of the chats. It was really interesting to see that it was difficult. If you're year 2 in your research, how do you come up with stuff? Because you're kind of like making stuff up, right? You don't really know. And that's a great question. But in the meantime, what you could do is work on your storytelling skills, right? And like breaking things down and looking for stories and other research. So I want to share this story. I think I covered this really quickly earlier. We have enterotoxicity of a non-ribosomal peptide causes antibiotic-associated colitis. This is a great paper, but I was able to find out, it was a beautiful story. I didn't see anything wrong with this paper. I was like, maybe this is the first paper that I've ever seen that was a perfect paper. And I was like, I don't believe in perfection. So I just didn't understand how could this be perfect. There's got to be something wrong with it. But then I realized why I didn't make it to Cell Science and Nature, right? I assumed. I like to guess things, right? I like to do my hypothesis. Can anyone tell me why not? By looking at this, by everything that you learn now, why isn't this one in Cell Science and Nature? What is it missing? What storytelling element is it missing? No broader impacts, stakes? Well, how about we just break it down? The resolution, let's see, got the resolution. They got causes, which I don't like the word causes. I tell people no, not to use the word cause. So let's say their resolution is causes. And the stakes is probably antibiotic-associated colitis. So they got those two things. Do they have a protagonist? And if so, what is it? Gabby hit the nail on the head. So the antagonist is the question. You have a protagonist, non-ribosomal peptide, and the conflict's enterotoxicity. There's no antagonist here. So there's no scar. So this lets us know that in terms of science or cell and nature, they don't have a mechanism, right? They don't know how this thing is working. So enterotoxicity of a non-ribosomal peptide causes antibiotic-associated colitis. And so how does that happen? And it needs to happen through another molecule, another something, another antagonist. So when you have your protagonist, you really do want to covalently link it to your antagonist. And I say covalent metaphorically, not real. But like, how do you link it together and tie those together? What they needed was enterotoxicity of a non-ribosomal peptide causes antibiotic-associated colitis through T cell receptor, B cell receptor, or whatever receptor it is for the that specific organ, right? Or that lines the colon, right? Maybe probably epithelial receptor, right? They didn't have that receptor, and they looked for it. That's why. And so maybe what you could do is, if you're early on in your process, perhaps what we could do is when you're reading papers, break down the protagonist antagonist conflict, and you'll start seeing why papers are published in certain places and not. And sometimes they'll have all 6 elements, but in the title, but if not, it's in the abstract or everywhere else. So great job, Gabby. That was a hard one. And you guys all nailed it. So you guys are really kind of getting these concepts very well. So let's, yeah, great job, Gabby. So evidence serves as a spine, but actually let's go back into the breakout rooms now, but now let's write the 6 storytelling elements. So we had a couple questions that said the group had an issue between separating the conflict and the antagonist. Typically, I think that's a really great question. And part of that is what does the antagonist do to change that protagonist? If you look at it like this, like someone was talking about, I don't know which group, but they have biofilms and some kind of species that impacts biofilms. But if you change the humidity, then it impacts, but they say the microfilm changes. So I think she mentioned that was the protagonist, but maybe the humidity changed, right? What is it that's changing that impacts the protagonist? So I think that's the key. And it's not so easy. We're trying to do this in like within 2 hours. That Nature paper with my friend who had published in Nature, his protagonist was a molecule that inhibits a KIX domain. And he had like RGT234, ICCB356, his name is protagonist. And he was struggling with naming the protagonist. I said, this is a horrible name. You need to change your name to something else. He's like, well, I'm a chemist. I'm going to keep this. I was like, that's great. But if you want to publish in Nature or a broader impact, you really need to rename that protagonist. So he didn't have an issue with the antagonist. He knew the antagonist. He knew the conflict. But he had an issue with just the protagonist when you have one element. And so I said, you have to do a new name. And he says, well, why don't you give me the name? And I was like, last time I did that, I was in the lab for 3 months growing up cultures because they said they want to put me on the paper. And I didn't want to do that again. So I said, you need to do it. And so he spent about 3 weeks trying to come out. His whole paper was held up. I said, you can submit it to Nature, but if it gets rejected because they don't understand who your protagonist, who the judge, then that's on you, and then you may lose that opportunity to get into that Nature paper. So he listened, but in 3 weeks he was highly upset, and then he got closer, and then he got to it's a kicks inhibitor, so they call it the iKicks, like the iPhone. I said, that sounds like a beautiful name. Let's go with that. And then that paper got a Nature paper. He went from being a lecturer at Harvard Med to being an assistant professor at Harvard Med, traveled all over the world, gave that talk on iKicks. Such a beautiful story. But because he didn't struggle with the conflict or the antagonist, he was struggling with the protagonist, naming the protagonist. But the antagonist normally does something to the protagonist to learn. We learned about Simba the most through Scar, that he was able to fight his biggest fears. I think it's something like that. I hope that was helpful. Did we have another question? Can the conflict be the same as stakes? It could be like a dynamic interplay. It could be. It could be. It depends on the field, right? Like if you're solving a complex structure, the complex structure, like say if it's at one point in the 2000s, not now, ribosomes were unsolvable by crystal structure. So just the problem was crystallography of ribosomes, but now they publish that all the time, so it's not a big deal. But the conflict, the crystallography of the ribosome, that was the conflict and stakes, right? And so it could be depending on where your field is. Great question. Conflict versus resolution, especially in context of ongoing research. So the conflict is your problem, your unknown. Like if what is it you don't know, and that's and you won't have the resolution until the end, right? We don't know if Simba's going to defeat Scar. I'm using that not to make it easy, but to really understand. We didn't know if Simba was going to defeat Scar. The movie could have ended differently. What if he passed away or died? It's Disney, so probably not. But every now and then Disney will show things a little different. But we didn't really know until the battle happens, right? And so the conflict is the problem, and we don't really know until it happens, right? And the resolution is what describes what happened afterwards. So the problem is the kingship, and then the resolution is that he defeats Scar, and that's something. So I hope that was a little more helpful. And so maybe when we start practicing hearing other stories, it can help as well. So let's go ahead, and I got a few more slides, and then I want to make sure that we leave time for the elevator pitch. All right, so we talked about that, the spine of the story, the beginning, middle, and end. So maybe sometimes it might be helpful just start beginning, middle, end. That can be helpful. Start big, like the 20,000 foot view, go down into the results, and then at the end you want to come back to the 20,000 foot view as well. So these are the little techniques that could help you get there faster. Your hypothesis and the storyline is really important. It's your draft, bend into a draft. I want to get to this point. The speaker and audience arc. So someone mentioned, is it difficult to not leave out so many details? So the speaker and audience arc. This doesn't make any scientific sense. This is just an illustration to kind of help. Say if you're on one end, you're the audience, and the audience on both ends, right? How much? Oops, this should be the audience and the speaker and the audience. I see now. Yeah, so here's the top is 0%. How much work does the speaker do? If you look at the top, it's 0% speaker, or does it do 50% or do 100%? And typically the work should be right in the middle. So the speaker shouldn't do all the work for the audience. If you're doing 100%, all of you guys are gonna go to fall asleep, right? Like nobody wants someone to go excruciating through all the details. Nobody wants to see that. So when you defend your PhDs, you can't throw your 12, 15 lab notebooks at your PhD committee. Not gonna work. You have to extract the information. And the audience, they don't do 100% of the work. They don't come up with everything, but the audience listens, and they listen to about, they do 50. So you share the work between the audience and the speaker. And it doesn't, so it's not a mathematical illustration, but I'm just trying to kind of show that. And what you don't want is a data dump with just too much evidence. The most important evidence is Timon and Pumbaa, even though other things that happen, there's his mom is quite important, but she's not in that outline. The mom of Simba's not in the outline. And so you have Timon and Pumbaa, then you have Nala, and you have Rafiki. You have other characters, but those aren't, Whoopi Goldberg and the hyenas are not in that dramatic arc there. So, and you got to be careful, too many characters, too many scenes. Just really focus. One hypothesis, one story. Audience will remember the pitch, that's fashion in the story, example of a scientific storytelling. So we're going to share our pitch. We have time. Do people want to hear my elevator pitch? Can you time this just for a second? Because I'm going to go through exactly what you're going to go through in a few minutes. So, 45 seconds. 45 seconds? Cancer. And cancer. What do you do? I study cancer, and cancer is nothing but uncontrollable cell growth. So in order for cells to grow, they need building blocks. And these building blocks are proteins, which are the bricks of the cell. So in the belly of every single cell, there's a brick making factory with assembly lines. And at the end of the assembly lines, there's a chief directing 2 factory workers. They can make more proteins or more bricks or less bricks. So it is what we want to do is instruct this chief to make less proteins in order to slow down protein synthesis and tumor progression, and also as a treatment for cancer. 45 seconds. 45 seconds. So was that okay for everyone if you put in the chat? You know, we're right at 6:40, so we have about 10 minutes to do the breakout rooms. But any final questions before we go into that breakout room? You know, basically, so you can use the same terms. I use the same EI5, but I didn't throw that at my grandmother, right? And so you just use different words for that. So hopefully that's okay. The elements of an elevator pitch that you need to hit: key, protagonist, you want your antagonist, and the conflict, and the scene, and the stakes. The resolution, you may or may not have that. So 5 out of 6, can we try that? I keep my fingers crossed. I believe in you guys. You guys can do it. And if you get 4 out of 6, that's great. And it doesn't have to be perfect. It's your first draft. So. And so before we go through a few more slides, just want to check in. How did that go for everyone? If you can put some comments in the chat. It was hard. Yeah, I know it was hard. Remember when I did my elevator pitch, I had a whole weekend to kind of craft mine. It took a while too. Change depending on whether I'm talking to grandma or another scientist. Yes. Yeah, and maybe it might change the characters, but maybe the naming of the characters. So maybe you don't call Simba Lioness Maximus or something, whatever by its species name, but maybe it's you know, like a lion or like a bacteria as opposed to like an archaeobacteria, right? And so yeah, it's hard to compact, but I think if you can get started, like the goal of this is if you can get started, it would be helpful. Doing practice when it helps realize different elements of the story. Yes, Stephen Chang, yeah. And I was jumping in, you know, and I would be surprised if everyone had something perfect. Typically, you know, like that takes some time, right? Like research, right? And so which is not just theoretical, but theatrical too. Yes, performing it is also important. And I heard some really great storytellers in all the sessions. I was trying to jump into a lot. And what I really enjoyed most is hearing the stories, but also how you guys were giving each other feedback and helping each other out. And giving, you know, I didn't even have to say, one session I was joined, I didn't have to say anything. You guys were just communicating to each other and saying maybe not to use technical terms, but like use a different way of explaining, like deuterium exchange. So great job on that group too. Yeah, and getting advice from others on how to do that. Okay, so that's great. So I'm glad it went through. Just want to end with you want to tell your story in the global workforce. It's and if you catalyze your story, your career, you catalyze your career by delivering storytelling pitches. When I went from Harvard Med to being the executive director of the National Research Mentoring Network, do you know my interview came down to that YouTube video you saw? It was like, how will he be able to inspire the whole country to do mentor-mentee relationships? He said one of the main reasons he brought me in for an interview when he saw that YouTube video. He said, okay, we need a guy like that to help communicate and tell the story of the National Research Mentoring Network. So it can help you with it's helped me in my career of storytelling, but it can also help you as well. Like if you're talking to a program officer or you know, or another professor at a conference, right? That can help you. So this is important work that you guys are doing. And it's important how you deliver the message. Like someone said, theatrical. Be passionate about it. Talk about it like as if you love it too. So, and these are all the people that made the Hall of Fame. This is a professor, National Academy of Science member on the top left, Gerhard Wagner. And these are all the people in order to get on this wall. They use this method. So if you publish your paper or something, like let me know and we'll put your picture on the Hall of Fame. So I just want to thank Julia and Alice. There was a lot of work that that had to happen in order for this to occur. And if everyone could give them a clap, a virtual clap, because there was a lot of work. We had practice sessions after practice sessions and planning and strategic planning, the best way to do that. And so, and I hope you guys show your appreciation to them and to the organization, because I think it's kind of great what you guys are doing. I think it's really impactful. You guys are going to really help improve the world. And so I have time for a few more questions and then we can turn it over to Julia. And yes, I do have elevator pitch for my grandmother. with my program officer. But what stays the same are the core elements. My Simba, I might call him a lion. I might call him by, you know, a different descriptor, whatever it can that your audience can understand. And so if you develop a new robot behavior, would that be your antagonist? Now that's a great question. I pose that to everyone. If you develop a new robot behavior, what would be your antagonist? Anyone? And I'm not here to say I have the right answer. It could be the code, I'm thinking, right? It may be the code that you do to describe that behavior. Are there some mechanical properties that you need to do? So the antagonist could be the difficulties in allowing that to happen, or what allows this behavior to come forth. It might be coding. I'm thinking more of the code, but I would have to know more about your research. And then maybe we just turn it over to Julia, because I want to make sure there's enough time to do some housekeeping. That's really important. And thank you all. It was a lot of fun. Any questions, you can siphon them through Julia. She can reach out to me. I can try to answer. But it was a lot of fun, guys. And you guys did awesome.